So thank you very much for being here. And okay, so let's move to the first slide. Okay, so today I decided to introduce you to a topic that is very important in the United States and in Europe. It's called cyber physical systems. And cyber physical systems are pervasive, as we will see later. And they are also very important in the domain of smart cities, which I understand is the main topic of this get-together. So first of all, definition, right? I'm a professor. I like to start with definition. So what is a cyber physical system? So in fact, we say that a cyber physical system is characterized by the tight integration of computation, communication, and control with physical processes. So think about a computer embedded in a physical device. So one example of, several examples of cyber physical system are shown in this slide. So a car is a cyber physical system. We know there is a lot of electronics in a car, and this electronics has intelligence and has a capability of measuring physical parameters that are typical of the actual device, which is a car. You can imagine of an airplane is also a cyber physical system. Again, is a physical system, but has a lot of electronics that controls its functioning. Buildings have become cyber physical system too, in the sense that if you think about air conditioning system, occupancy measurement, the security of buildings, the control of egress, for example, in an emergency situation. All of this put intelligence inside a building where we live and work. Another classical example of cyber physical system is a manufacturing plant. Is wherever you build other objects like cars or even computers, anything that you can think of. It is a cyber physical system because the machines that you use to assemble the pieces to make your product have indeed a lot of controls, and these controls are embedded into a computing system. Now, we know about a lot of buzzwords that have been going around in the last few years. We know about Internet of Things, for example. If you look at publication everywhere, Internet of Things is a very hot topic. And Internet of Things is indeed the notion of objects that communicate among themselves in a way that is similar to Internet, right? And so that is the reason why it is called Internet of Things. Their scope is not to communicate to a human, but to communicate among themselves. Now, if you think about it, this is a particular cyber physical system. So it is a subset of what we are talking about. Other example is Industry 4.0. Industry 4.0 is a very well-known term that indicates the effort that we do to make our manufacturing plant more digital. And we already say that actually manufacturing plants are example of cyber physical system. So that is included in there. Industrial Internet is another way in which people think about this. Smarter planet. A smarter planet is a way in which IBM is relating to the environment where trillions of sensors are connected together and provide intelligence. The fog. The fog is also a term that is very much used in the United States. Has been invented, if you like, by Cisco Systems. So this domain is probably the most interesting from industrial point of view that we can think of today. So I'll start by talking about the relevance of CPS and where CPS is today. And then we'll project what the future for CPS is going to be in the next few years. So I don't know how many of you have seen The Good, the Bad, and the Ugly. It's a famous Italian movie, actually. It's a Western Italian movie. But we are going to see the good of the cyber physical system, the bad, and also the ugly, which is actually not a minor aspect of it. So first of all, what is the relevance? What are the good things about cyber physical system? Now, this one is a picture that I took for the McKinsey report on disruptive technologies that came out in 2016. Now, these are the list of 12 potential disruption technologies that we can see. And so among all these 12 different technologies, we can see that there are 2 or 3 that are squarely into cyber-physical system. Internet of Things, advanced robotics, autonomous driving are all related to that. Now, what is the economic potential of cyber-physical system? If you just look at the last column of this slide, you see that just picking up Internet of Things, cloud technology, advanced robotics, and autonomous driving, which are all cyber-physical systems, you sum up that, and it comes up to about $100 trillion of impact. So granted, this McKinsey, we all know, is a marketing company when it comes to this, and we know that marketing companies tend to exaggerate. So let's assume it's not 100 trillion, but it's still a lot, right? So this is what we need to worry about. So the relevance is there. So it's a huge potential. So how do cyber-physical systems fit into smart cities? Again, it's the theme of what you have been, we will be talking about here. And the issue is that if you think about what it takes to make a city, a normal city, a smart city, we have to look at the kind of things that take place in a city. And so, for example, is the management of resources like gas, like electricity, like water. And so one aspect of smart cities is smart water. And what is smart water all about? Is ways in which you can manage the flow of water into a region or into a city in such a way that you don't waste water. And you know, water is becoming a scarce resource nowadays, and so you have to be very careful not to waste it. I don't know how many of you know, and I was very surprised when I read about it, but in an advanced country like Canada, almost 50% of the water that is distributed is lost. It's lost because there are holes into pipes, because there are valves that don't work properly. And so the point is, how do we recognize that there is a problem into the network of distribution such as water or electrical energy for that matters? Then we need to instrument it, so we need to put place sensors to see where the problem is. And then you have to fix it. So there are some of my colleagues that have developed small robots that actually travel through the water pipes and go to the place where there is a leak, and they fix it from inside. You know, so this looks like a fantascientific kind of dream, science fiction, but it is not. It's actually in a few years we will have these small robots traveling in pipes, water pipes and gas pipe and the like, to fix potential problem. The other thing, and especially so important here in India, is traffic, right? Traffic is a mess everywhere, but in here I would say it's more mess than in other places. And so smart traffic is everything you can do to improve the situation of traffic. Now, if you look carefully about the way in which we lose time in traffic, it's all related to the fact that we behave in a way that is uninformed. So we don't know where traffic jams are. We don't know that, for example, by slowing down, we actually speed up our travel. We don't know that, for example, trying to overtake a particular car in a particular zone can cause an accident, and so on. So smart traffic is about making all the aspect of driving and going from point A to point B better, more efficient, less energy consumed, less time wasted. Smart energy, we all know about smart grids. Smart grids are an example of smart energy distribution. And so why smart grid? Well, the reason why we are moving towards smart grid is not only because we need a better efficiency in distribution of electricity, but also because we have renewable energy that is being put into the network, and renewable energy is actually an unpredictable source of energy. So you need to be able to absorb this energy into the network, and at times this energy is not available. So you have to be very careful in planning Otherwise, your network goes unstable. So you can create all kinds of problems to everyone if you don't control it in an intelligent way. Which brings also to the problem of inventing new devices to store energy when you have a surplus of energy that can then be reintroduced into the network. So what are the key drivers of smart cities? So first of all is a constantly increasing urbanization. We know that most of the people in the world tend to gravitate around mega cities, and this trend is actually increasing rather than subsidizing. There are insufficient infrastructure, traffic, garbage collection, garbage disposal, energy distribution, even internet connection is becoming scarce. So you may have had the experience of being in a zone which is covered by Wi-Fi, but you cannot get in because there are too many people in the network, and so there is no possible access. This is an example of scarce resource in front of an increasing demand of such resource. Managing vital services, like, for example, security, so crime prevention and crime fighting, healthcare, transportation. So you may have to make better transportation, besides the fact of your car, but there are also public transportation aspects that you need to worry about. So all of this is, in a sense, how you better plan. A smart city is a city that plans for the welfare of its citizens. So make sure that everything you need is there for you to use when you need it. Making the city competitive. Now, this one is an aspect that not too many people realize, but there are several areas in the world that are competing for talents. One case in point is, for example, in the Arab countries like the United Emirates. They are trying all possible ways to attract people, universities, innovators, engineers, financial people, because they realize that that is the blood of the nation. And without this influx of human capital, they cannot do much with their money, and they have plenty of money to be managed, believe me. And so the issue is that how do you make the place attractive to other people? One way is to make it safer, place cleaner, better managed, and all that kind of nice stuff. So other key drivers we have to look at is from the point of view of who is pushing and who is absorbing. So there is a technology push when we talk about cyber physical system in smart cities. And the technology push, we already know what they are, but we will list them. And the other side is the demand pool, so what people want. The technology say, this is what I have to offer, and people say, this is what I want. So on the technology push, you have to see sensor technology, big data analytics, cloud computing, control and optimization. So this is all what we work. I mean, I assume that all of you work in engineering one way or another. And so that's what we're working on. So we are good at that. So we want to do better things. We want to develop faster and a cheaper way of doing computing, smarter analytics to analyze the data that you cover. But for what? What is the issue? Now, the point is that the more you instrument a system, the more you place intelligence into the system, the more fragile it actually becomes if you don't control it. So you can actually, by doing a lot of technology and putting a lot of technology into everyday's object, you can create more problems than you actually solve. And so we have to be very careful in thinking about what is the downside of technology, because we may make life of citizens in smart cities miserable instead of making it better. And on the demand side, you have, of course, increased demands on safety, security, better healthcare, traffic and resource management, better energy efficiency, more responsible production, also to prevent the environment to become completely wasted. So the issue of environment is a very critical one. I just read on the New York Times 2 days ago that actually India has overcome China in terms, in the bad sense, in terms of air quality. So we need to worry about all what we do also from industrial point of view, not to kill us all, which we have to be very careful about not destroying the environment where we are in. So this has to be fulfilled with reliability, of course, and without, important point, damaging privacy. Now, the issue is that many people today are very afraid of what they give out in terms of knowledge about themselves. And that's the privacy issues just that. And so, especially in the United States and in Europe, there is a great concern about who has access to my personal data. And so you have to sign all kinds of papers to do anything, just to say, I know, you know, you're going to use my data and I'm okay with it. Now, of course, you have to read the fine prints because you may give up much more than you wanted to. So that the privacy issue is another big problem that we need to worry about. So what is the future vision of CPS in smart cities? So there are two spatial scenarios that are of interest. And these two scenarios are classified as being the best of time and the worst of time. The best of time when everything works fine. And so in that domain, we have to help running the infrastructure. We have to empower the occupants in their daily activities, providing better interfaces, better mobility, and so on. But we also have to be careful about the worst of time. So when we have disasters, natural disasters or otherwise. So we have to be able to safely, securely align both stationary, so biohazard detection sensor, and mobile, like UAVs, robots, and humans, resources that need to protect themselves. So the future vision of CPS is, in both scenarios, is that you have to think about the smart cities combined with management of fixed infrastructure, so environmental monitoring, energy usage, tracking and mapping, mobile systems, and immersive humans, meaning humans that interact seamlessly with the technology environment. Now, of course, this involves discovering and integrating sensing, actuation, and computing. And so that is the novelty, if you like, of the direction of both industry and research, is about that integration of sensing, actuating, and computing. So because of the importance that we just said, you can take a look at what happens in the startup worldwide, and in particular the startups that have been funded in Silicon Valley. And these startups belong to a series of categories: parking, grid energy, data-driven urban planning, smarter transport, environment sensor, connectivity, waste management, traffic and transit data, water, software analytic, and disaster management. So these are the categories. And you will be surprised how many startups are in this domain. So there are 80 plus startups in this domain. And this is a map of all the startups that you can see in Silicon Valley. So the investment is about $1 billion in this domain. So once you have this concentration of resources being put on these topics, sooner rather than later, you're going to see new companies, new large companies, new big investment being effective at changing the way in which we live and work. Now let's look at what Google has been doing in this situation. The big electronic players, Google, Apple, which are the internet players by definition, well, actually, they are becoming cyber-physical system company, one way or another, so much so that Google has changed the holding company to a name of Alphabet, meaning that not only they deal with internet, but they deal with all kinds of different industrial domains. So you can see that one of the largest acquisitions that have been done in the last 3-4 years has been Google when it bought for $3.2 billion a thermostat companies, right? You think thermostat? What the heck is thermostat anything to do with Google? Well, the point is that thermostats are a good entry points in your homes. And so if you think about smart cities, one essential component of smart city is your home, so the smart home. And their view is that through the thermostat is a good place to own your smart city complex of homes. Now, they also bought for an undisclosed amount, because the company was private, Boston Dynamics. Now, Boston Dynamics was the most advanced robotics company you can think of. And if you go on YouTube, you see these monster robots that go around, and they are really scary, and they have been designed actually for military application. Now, it's interesting that in this particular domain, Google has tried to do something with this because they know that this is a direction for the future, but actually they have not been able to dominate that market in the way they wanted, especially in terms of industrial robotics and the like, and they actually sold it back, right? So they dismissed that investment. But the interest in this domain remains. In fact, we all know their work in autonomous driving cars, so cars that drive by themselves. And actually, if you look at the number of miles that autonomous cars have driven, Google is by far the most advanced in the world about autonomous driving. They log millions of miles to test their equipment and their software. Now, what makes, for example, just to think about what is the enabling technology that these activities require. So in the case of autonomous driving, again, the key point is sensing, is being aware of your environment and to react to it. So the sensing is actually the most important part. Without a comprehensive sensing, you will never be able to do autonomous driving. So among other things, an important way is to provide your car with eyes. So we know that cameras are available at lower price, so you can see around you very well. But it is even more interesting to give eyes to the car that are much more powerful than yours, which implies that you want to give it radar or LiDAR capability to the car, so that you can see around the corner. So you can even predict what is going to happen while you're driving, so that you don't get into an accident. Now, the problem is that for a radar, the cost up to a few months ago was in the thousands. So one radar, $1,000. So you can imagine how many radars you may need around your car, and you see that the cost is prohibitive. So autonomous driving would be too expensive if you needed to have these radars all over the place. But, as always, the actual hardware technology has come to the rescue, in the sense that now it is possible to do radars, so devices that can be integrated in a single chip that can be made to cost about $10 or less. Now, at this point, the issue of sensing for whatever cars, no matter the top-level cars that already have radars all over the place, but even the normal cars that cost $5,000, can be equipped by this kind of devices, which then makes it possible to deliver autonomous driving to a much larger category of cars. And in fact, NXP, before being acquired by Qualcomm, had announced that they are looking at all CMOS radar future, and next year they promise that they are going to come up with such chip for delivery. Now, this is an important point, because too often people think that the future of technology is only in software, and it's all about machine intelligence, it's all about artificial intelligence. That is not the case. Now, artificial intelligence, smart programming, machine learning, and all of that is totally useless if you do not know how to capture data upon which you then do analysis. But the data capturing, the capability of measuring what is around you, is an enabling technology for the future. So, a strong message that I would like to give to the students here in this room is the fact that if you want to really master the technology for the future, you have to be interdisciplinary. So you have to know about hardware, and you have to know about software, and later on we will see also how important it is to know about biology, because not only cyber-physical systems are going to be important, but also bio-cyber physical system. And that is, there are some examples of application of technology to biological systems that are rather scary, but they are possible, and they will be determining what the future of technology is going to be. So Apple also, we know, has been very active in the autonomous driving domain. Now, the interesting point is that Apple never said officially that they were working on autonomous cars. But we know for a fact that that is the case, and they also kind of wavered on their investment. So up to last year, I've been able to extract an interesting information. So the amount of investment that Apple had on autonomous driving cars is more than the integral of everything they spent to develop all their devices before. So Macintosh, iPod, iPhone, whatever you can dream of that Apple has made before getting into the autonomous car, all of that costed less than getting to autonomous driving, which also tells you that the world of the future requires a variety of different players, and some of the players have to have a very deep pockets. They have to have a lot of money to be able to do that. Now, it's interesting that one of the most relevant application for Apple to move into the autonomous driving domain is electrical vehicles. So electrical vehicles was their bet. While Google didn't bet on electrical, they say whatever car we are going to do autonomous driving. Apple said we need an electrical car. So if you think about electrical cars, we know that Tesla is there, and we know that Tesla is very successful. And indeed, Apple tried to buy Tesla 3 times. And they couldn't do that because Elon Musk said, go, right? I don't want to merge with you, so go away. But that was one way for Apple to get into the car domain. The other way is to make tons of batteries. So actually they joined with Tesla to build the gigafactory for batteries. So in fact, if I had the choice of where I could invest in terms of venture capital money, definitely energy storage would be a very important place where to invest, because this is going to be another of these key enabling technology we were talking about before. So Google in talks with OEM to build up their car, Apple is forming an auto team, and so on. These are news on the 2015 domain. So what is the bad? You know, it's a way of seeing all this money piling up, everybody being interested, the electronic companies getting in. You know, by the way, I worked for a long time with General Motors, and about 8 years ago, General Motors started looking in the mirror and say, well, we have a real problem if the companies like Apple and Google come into the market of automobiles, because it's the different kind of automobiles we'll be talking about. And so the question is, what do we do to survive this GM? Now, I happened to talk to the CEO of Daimler at that time. Was not just dismissed Chrysler, so it's just Daimler-Benz. What is his name? Well, anyway, will come to me. The CEO of Daimler, and he said, I don't care about Apple. Who cares if Apple wants to come into the automotive domain? I'm not scared. Like, they shouldn't be scared if I come into the smartphone market. You know, that's a very dangerous way of thinking, because you are not considering your competition of the future in a clever way. So when you are in a company and you want to survive, you have to be paranoid, as Andy Grove said, of Intel said. You have to look all over the place, and you have to have in place alternatives, strategies to cope with a revolution. Now, what is the problem, for example, for cars? That it's so difficult to make cars today. Well, this one is one example. So if you look inside of the car itself in terms of the electronic subset of the car, that's what you see. It's an horrible mess. And that is the reason why often your cars have to be taken to the
dealer to fix is, in general, is electronic system. And why? Because it's too complicated, it's too complex, and it's non-predictable. So one of the steps that we need to do is to reinvent the car from inside out. So we really have to think to a new architecture, to a new way of bringing together the various subsystems. But what is worse, the ugly side, is that when technology is creating problems that makes us go back 10 years, 100 years, and so on, is the negative effect of accidents or things that we didn't consider before. So there you go. So this famous Tesla accident that was, in Florida. So there was this guy was driving in autonomous mode, then a truck turned, and the car slammed into the truck, right? And so everybody said, oh my God, you cannot possibly trust autonomous driving. And so that was a huge backlash on the situation of autonomous driving. So there was a statement issued by Tesla that was explaining the kind of surrounding evidence that made the car actually not see the truck. But if you want to have my honest opinion, you see where I point the arrow there? That is where the radar for a Tesla car is. There's a single radar. Remember how much it costs, the radar today, right? It's only one. And it's below the top of the hood, right? And so this radar probably was not enough to detect what was happening in front of it. And so the point is that the technology did not make a mistake, is that it was under design, if you like. There were not enough sensors to detect what was going on. But okay, so this may be the case, but the point is that this accident actually set us back. Now, another accident that is waiting to occur is about cybersecurity, vehicle cybersecurity. So our cars are actually very easy to penetrate. So almost anyone can get into a car and make it do whatever you want. If you go to YouTube, about 4 or 5 months ago, there was this video going on that was showing a FCA Jeep car being taken over by 2 hackers that were in an apartment, and this car could, turn around on itself. It could go into a ditch, and with a driver in it that couldn't do anything. So now imagine if a terroristic act is going to take place in this domain. So take a car, take it over, make it slam against each other, block all the traffic in Los Angeles. You can imagine the huge damage that something like this could make. So these are the dark side of technology, are the issues that not many people look into, that people should be very aware of. By the same token, our distribution network, like water or also energy distribution, is very easy to penetrate. So forget about entering into computers for banking system and all of that. And the damage there is only economical, if you like. Or if you go into the Hillary Clinton, headquarters, what kind of damage that can do. But if you take over, for example, a power distribution network, you can make entire cities shut down, no more electricity. You can imagine the kind of damage that something like this could make. So technology is there. We can do a lot of things, but we also have to be aware of what are the negative side of introduction of this technology, what are the dark side of the technology, and what can we do to prevent these things from happening. So this one is actually the various places where you can get into a car. So not only you can get into a car by usually wireless connectivity, entertainment system, cellular communication, that's easy. But there are other things that you have to worry about in a car. For example, you know that in United States it's compulsory to have a TPA device. TPA is temperature and pressure sensor that has to go into tires, right? That's a small electronic device which communicates with your instrumentation, right? So that is a wireless connectivity. You can enter into the car through that connectivity. Another example, when you take your car to a dealer, you have a plug, right, where you put in the diagnostic device. That is an open door into your electronic system. So if I'm a bad guy, I go around at night, I plug in the thing, and I discharge a virus, and your car is incapacitated. It's as simple as that. It's not protected. I can do that anytime. So these are, there are about 100 points where you can enter into a car. So most of these are being taken care of. But this just to tell you how easy it is that something bad may occur in that domain. So Apple and Google, as a consequence, are slowing down. So Apple is said to be rethinking strategy on self-driving cars. They actually fired about 200 people in their autonomous driving operation. They never said it, but you can see people in the Silicon Valley going around and looking for a job. But on one side, we have Apple and Google say, oh my God, maybe autonomous driving is a problem. What do we do? But companies like Uber realize how advantageous this can be to take over completely the the driving and the automotive domain. So Uber is actually, today, the company is investing most in autonomous driving. And so they have purchased a company called Otto that has autonomous truck driving. Now, what happens to the traditional car companies? So GM has acquired a large stake into Lyft, which is the competitor to Uber. So you try now to reposition yourself when these players, they keep on coming from right and left. And you have to be careful about who are you fighting, on which turf. So that is what is exciting for the future, especially for you students. You are in the middle of a very interesting battleground where technology and the capability of putting together different concerns are going to be a key competence. So in some sense, I wish I could be 18 to be into this and try to make a dent, to make a change. And again, BMW is to develop driverless car tech with Intel and Mobileye. You see, that's another way in which you can fight the competitors. Instead of investing into someone, you partner. And so you have BMW, a very traditional car company, together with with Intel, which is a very traditional chip making company, with a startup, no longer a startup, like Mobileye, that does the vision chips, the chips that are actually empowering the collection of visual data and radar data to make the car be intelligent. So this one is the startup domain in automobiles. So you see tons of companies all over the place, from connectivity, from communication, from car automation, auto repair, tires, you name it, right? So notice that the last company before Tesla who went public in automotive in the United States was Ford in 1953. So you see that something that is an old technology, almost dead, right, all of a sudden becomes a center of attention because we are on the edge of a revolution where the companies that we know being the dominant players are going to disappear, the dinosaurs, right, maybe. Or maybe they can become the mammals of the future, right? So they can become more nimble, they can change their skin, they can do something about this. But this is a sign of a revolution to come. When you see a lot of startups, there is something that is taking place. So look at the challenges for automotive ecosystem. You have emerging markets. You have also another important, super important aspect that we don't think about, are the legislating autonomous driving. So the laws. So when Tesla had that accident, nobody knew how to assess the liability. So who is going to pay for what? In the end, in fact, Tesla was kind of allowed to say it's not our fault. But it took a lot of thinking and trying to put things in context and so on. So the point is that how you legislate, how can you place blame? So who is at fault? Now, imagine that you are getting a car from General Motors. So you drive a car from General, but the intelligence system is Mobileye plus Intel plus, I don't know, Google plus whatever. Now, the car has a crash. Whose fault is it? Is Intel, Mobileye, the software by Google? Is the mechanical component? You don't know. It's too complicated. So you have to rethink completely the liability scheme, and you have to legislate what is allowed and what is not allowed. By the same token, you have to change the standard. The safety standards have to be completely changed. No matter what, if we are going to have autonomous driving, even if it is not perfect, we are certainly going to kill fewer people than today. This year, in the United States alone, we had 40,000 people dead in the street. 40,000 people dead in the street. So many more that you can ever imagine that people have been killed in any other kind of accident. And so for that reason, the insurance companies all of a sudden say, who do we insure? Do we insure the driver? But he's not driving. So we cannot insure the driver. He's not liable. So we have to insure the car company. But then the car company say, well, why us? The liability should be in the components provider. And so now, what happens? And so even something like as mundane as insurance policy has to be radically changed. So technology is changing radically. Also, well-established industries that have nothing to do with technology. Insurance, at least in principle, have nothing to do with technology. But there are, I'm working with the largest insurer in Europe about how to make sure to place the blame on accident today, where we don't have autonomous driving. But for example, you have a head-to-head collision. So whose fault is it? Now we put the sensor in the right place. We can reconstruct the accident right there, immediately. And we can say it's his fault. And so the payment for the damages can be placed immediately. So like in a week, without the need of having a appraiser of any kind of any type. So even insurance companies are turning into potential big user of technology. So this is the legislation in the United States. There are many states, as you can see, where legislation has been passed to regulate autonomous driving. And this is a very important point because you want to be able to say, again, if you can or cannot drive in that domain. So this is the present, right? We have already seen a lot of future kind of connotation, but it's still the present. Now, what about the real future? What are we going to see in a few years from now? So, well, let's look at the way in which the information technology has changed. Now, you see that? This is my life in one slide. So when I graduated, that was it, right? We had centralized computing. We didn't even have graphical terminals. We had, punch card and the like. So granted, I'm qualifying myself as a dinosaur, but, at that time, that's what we had. Now, fast forward to today, and now today is a mobile access time of information technology. So you can access the internet through your devices. Everything is connected. You can have access to vast amount of data. You can play with it and so on. But what is the future? The future is this one. It's what we call the sensory swarm. So actually, if you believe to this picture in the sense that the future is all going to be based on sensing devices. Remember that we said for cars, you need the radars, leaders, this and that, and up and down, eyes and ears to the cars. The future is going to be so interesting that everything is going to be instrumented. In this room, actually, I would not need this microphone because I could speak like this, and microphones will be all over the place, embedded into the walls. I would not need the projector there because I would do like this, and you will have a 3D image of my slides coming in front of your eyes, either through glasses or just an holonomic picture showing up in the center of the room. So that's what is going to be possible because of the advances of technology. Now remember that we are on the edge of 1 nanometer devices, right, which is very, very small. And so we can make 1 millimeter by 1 millimeter. We can make chips that are so incredibly powerful that everything that we know today is going to be a different thing. And the connection to the cloud is going to be so pervasive and so fast that you can do any kind of computation or analysis on the data real time. Okay? So that's what the future is going to be. Now, this is the case. Do we need a cell phone? Do we need a laptop? We can communicate with our body, right? We can communicate with the internet, with gesture. We can talk to the internet. You know, one of the most popular devices today is the Echo by Amazon, right? That is extremely liked. And then you talk to that device, right? It's natural speech understanding. So we will talk to the technology. We will not need to learn the language of technology. Technology learns our language. And so that is, if you like, a Copernican revolution. So it's changing the factors of the equation. So in fact, the prediction is that there are going to be 7 trillion devices very soon, by 2020, and which means that we are going to have 1,000 devices per person. 1,000 devices per person, including small kids, you know, elderly people, everything. Everybody on Earth is going to have a 1,000 device at your, for your use, which then brings to the point that the human is going to be immersed in technology, and not the technology. We need to interact with the technology. The technology needs to interact with us, and so that is the concept of immersed human. So the human is immersed in a very structured environment. So about the vision in 2025 is the fact that you cannot now have an application that runs on one device, like on your cell phone. The applications are going to run in the environment. So it's going to be distributed, widely distributed. So which is a very important point also for availability, because if something breaks and you have 1 trillion devices, other devices can come in and fill in. So you will never have to experience the loss of connectivity, the loss of touch with your environment and so on. And so this is going to be a humongous network, distributed, adaptive, hierarchical, hybrid control problem, which is great for people who like mathematics, because to be able to manage this stuff, you need a lot of mathematics for sure. So actually this swarm is coming, right? So which means that, I don't know how many of you have read the book by Michael Crichton that talk about the possibility of these tiny devices that are actually revolting against humanity and are killing everybody on sight. So that's a swarm, right? So we hope that is not going to happen, but in principle it may happen. So we need to do something about it. So this one is for the students. What do you need to do in order to master this technology? Well, you have to know all of this stuff, right? This the kind of research program that we have at Berkeley right now in collaboration with many universities, and this is also called the Swarm Lab, the lab that deals with the swarm system. And you see that there are all kinds of technologies that have to come together, from IC design, from computer science, to reliability, to ways in which you can distribute computation and so on. So, and this one is about 25 different professors in 10 different universities that are together to solve this. I promised you about the bio-cyber-physical system, and I said, well, cyber-physical systems are all what we talk about today, but now let's think about the way in which this physical system can interact with our body. And now we are the cyber-bio-physical system. So let's see how this kind of may work. So the idea is that we are going to be instrumented. Remember, everything is going to be so small that you can place sensors everywhere. So even in our body. Now, I am a runner, and I have a Fitbit device here. And this Fitbit device tells me a lot of stuff about what I do, how much I walk, what is my heart rate, how fit I am, what is my VO2 consumption, and all of that kind of stuff. But imagine that you have devices that are so accurate, that can take so small and so accurate, they can take your heartbeat and measure your electrocardiogram in real time. And you can be monitored every day, 24 hours a day, for 365 days a week, so a year. So that is, this one is an example. So today your electrocardiogram is what you see on the left, but if you see what will be possible on the right, is a very tiny device that is going to be attached to your chest, and it's costing less than $10, so you can throw it away after a month. When the battery is over, you replace it. You don't even feel it. I actually tried. This is a startup that actually I'm a co-founder of. It's called H-Micro. So this is possible. Today, we are going to sell it in the next few months. Now, this is another interesting bio-cyber-physical system. That is a contact lens. It's a Google contact lens. What do you think is that kind of round thing around the lens? That is actually an antenna. And what is in the middle, on the side, of that tiny chip on the side? That is actually a chip that can measure the glucose that is present in your tears. What is that for? For diabetics, right? So today you know that you have to prick the finger, get the blood, and all that kind of stuff. Besides being expensive, it's very obnoxious, right? And there are many people who are diabetic. So this one is going to revolutionize the way in which you measure insulin, the amount of glucose in your body. Now, worst of everything is that we can place chips in your brain directly. Boom. So now, how can we do that, right? You can imagine, oh my God, a chip in my brain. Oh, ouch, right? It's going to ruin my brain. No, and we'll see why that is the case. Because they are so small that these kind of probes that you put in contact with your neurons are so much smaller than the neuron that the neuron doesn't even feel it. It doesn't even see it, right? And yet you can measure what happens in your brain. And what is the application for that? Where there are, you see, this is the actual probe, and you see when you go below 0.2 millimeter, the neuron doesn't get destroyed. You see that kind of horrible device on the right? This is very small, and the pins are the ones that you prick into your brain, right? So what is the use of this? So one thing is to cure diseases, right? For example, you can apply deep brain stimulation. Deep brain stimulations for Parkinson, for Alzheimer, for deep depression, and it's very effective. But the point is that you have to apply an electrical current. And so with this device, this electrical current is not felt. Remember that many years ago, many years ago, people knew that giving electricity to your brain was good for this kind of device. You know what was the electroshock, right? And people died or were suffering tremendously because of the electric jolt that we're getting. Same thing, except that now you don't even feel it, right? So, but it is very effective, and so we can apply things that were known for decades in a much better way. Another thing that you can imagine is that once that I have a connector in my brain, and I can send the measurements through an antenna, I can imagine of controlling and accessing the internet with my thoughts. Forget about, sensor this and that. I can directly connect to the internet. I can directly connect to people without speaking, just thinking. Now, what is the most difficult part of this is to decode the thought and to send the decoded signal, because we know that if we think about something, our brain wave move in a particular way. But we have to associate this brain wave to have a meaning, and that's not easy at all. So in fact, today, it is possible to do so. For example, for people who have had a breakage in their backbone, and they can still control their arms through these chips. But you have to train people to think in a particular way so that the devices can talk to each other and you can actually move your arm. So this is actually a startup, again, another startup in Berkeley, which is called Cortera Neurotechnologies. And this is the device that you see on the left. And this is actually placed, implanted in your brain, and does again the deep brain stimulation and communication with part of your body. So it is a real technology, so I'm not kidding you. So final words of wisdom, so what have we learned? So I believe that one thing that we have to be very careful about is how we teach things to people. So now, in engineering, and I guess most of you are in engineering, often we are taught practice. So how do you design something? Oh, this is the way it is done. So learn the way it is done. And this is what I call design practice. Now, unfortunately, design practice are not always based on fundamentals. And so we as a university professor should always pay attention to what is going to last forever. And what is going to last forever is more like principle, not techniques. You have to imagine what it is that all this stuff that I show you is based upon. And what I told you is all based on the foundational things, which are biology, physics, mathematics. And so without this deep knowledge, you cannot master the future, guys. So don't feel, annoyed by professors that teach you about transistors. You need to know what a transistor does and how the hardware works. Don't be annoyed if people show you how to solve differential equations or what are the properties of differential equation, because no matter if you like it or you don't, the future is going to be differential equation, which is the interaction between the physical world and the computing world. So you need to know this, and physics, of course, being the basis of all of this. So anyway, in conclusion, so the point is that we show about, the use of the CPS, the bio-cyber physical system, and all of that. But this conference is about smart cities. So the point is that no matter which part of technology you're going to look at, there is a tight collaboration among lawmakers, policymakers, urban planners, architects, technologists to make smart cities a possibility. So once more, a wide knowledge basis. So in fact, in our educational program in Berkeley, we have moved towards this very broad knowledge basis, and then you go deep into something. But you have to know about a lot of stuff, because otherwise you cannot talk to the people that are going to develop with you the new products. And so you do need to have this collaboration things. Now, if I look at one of the most important problems in smart cities are the city managers, the politicians, the people who manage the city. They don't know A from B. They don't even know what a TV controller is. They're just out of the world. And so you have to interact with these people. You have to make them understand what the city of the future are going to look like. And this is something that you will have to learn. So the research agenda, again, on smart cities and the like, have to be focused on dynamic deployment of application on large distributed computing platforms that are interconnected with the physical world. So remember, this is going to be the future. Connectivity between the physical world and the cyber world, cyber physical system. Thank you very much.